Okay, so let's start once again today. So first of all, what are the things we have already learned? Just recap of that. So the first thing is the divisibility rule. Do you know what is the divisibility rule of 2?
Yeah.
Tell me.
The last digits should be 2, 4, 6, and 8.
What about 0?
Oh, oh yeah, 0, 0, 0.
Okay, and such numbers are known
Yeah,
as
any even number.
yeah, and such numbers are known as even numbers. The numbers ending with 1, 3, 5, 7, and 9 are known as odd numbers.
Odd numbers.
Okay. What is distal sum?
It's like the addition of digits when you add all the digits.
Very good. So can you tell me what is the divisibility rule of 3?
Uh, they have to have a digital sum of 3, 6, or 9. Right?
Very good.
Yeah.
The decimal sum must be 3, 6, and 9. And while adding that, you should ignore the numbers which are forming 3, 6, or 9.
Yeah.
Okay. Okay. What is the divisibility rule of 4?
So if the last two digits were 0, 4, and 8, the number before them should be even. But if the last two digits are 2 or 6, the number before it should be odd.
Very good. So the last two digits must be divisible by 4. And how to check it? So if the last digit is ending with 0, 4, or 8, the previous digit has to be an even number. And if the last digit is ending with 2 or 6, the previous digit has to be an odd number. Very good. What about the divisibility rule of 5?
The number should end with 0 or 5.
Very good. Okay, good one. And you know what is the divisibility rule of 9? Have I taught you? What is the divisibility rule of 9?
No.
Okay, no issue.
No, you haven't taught.
Do you know what are prime numbers?
Yeah.
Tell me what are prime numbers?
There are numbers with only 2 factors.
2 factors. Very good. What is the lowest prime number?
2.
Wonderful. What is the even prime number?
An even prime number 2.
Very good. Okay. Can you tell me all the prime numbers from 1 to 100?
Yeah.
Just wait. Let me put on the timer. So your time starts now.
2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 73, 79, 83, 89, and 97.
Very good. You missed 71. Okay.
Oh.
Yeah, you
Yeah,
missed.
sorry.
You said 73,
Yeah.
79. So you have to remember in the line of 70 there are 3 prime numbers: 71, 73. Very good, very good. I am really happy with your performance
Thank
now.
you.
Okay, good one. But keep repeating it. Okay. The next day also I am going to ask this until unless I am satisfied. The time you have taken is 18 seconds. It has to be reduced to 15 seconds. Okay. Now
Okay.
about the prime factorization. But before that, I would like to know: do you remember all the exponential values that I taught you?
Exponential,
Like 7 cube. What is 7 cube? Tell me. 7 to the power 3.
yeah, yeah. Yeah.
Yeah, please tell me what is 7 to the power 3?
It's 340.
Yes, 343. Yes.
Okay.
See, 7 cube. How you can make 7? You can make 7 by adding 3 plus 4 and 4 plus 3. So it is 343. Okay, what is 3 to the power 5?
3 to the power of 5, 243, right?
Very good. What is 9 to the power 3?
729.
Very good. What is 3 to the power 6?
729 also.
What is 4 to the power 5?
1024.
Very good. What is 2 to the power 12?
4096.
Wonderful. What is 5 to the power 6?
5 to the power 15,625.
Very good. Good one. What is 2 to the power 6?
64.
Very good. What is 2 to the power 8?
256.
What is 8 cube?
That's three. No, 512.
Okay, so have you remembered this or you are watching and you are saying?
Huh?
Have
No,
you?
some of it I'm trying to remember, but if I don't uh remember, I just have like a sheet. Is that okay?
Yeah, that's okay. No issue.
Uh,
But you have to remember ultimately. All right.
yeah, like some of it I'm trying to remember, but the ones I don't, I just use this sheet.
Okay, so please watching sheets every day at least for a minute, so that you can have a look on it, and one day there will be a day in which you will understand everything. Okay. What about the fractions? Have I taught you about the fractions as well?
Yeah.
How many kind of fractions I have taught you?
So far, five.
Five. Tell me
You
what is the
taught
first?
me
What is the first kind of fraction?
proper fraction, right?
Okay. What are the properties of a proper fraction?
Properties like the numerator, the numerator is less than the denominator, right? Yeah, yeah.
Very good. Very good. The numerator is less than the denominator. And second property?
It's second property. Wasn't
It's
there like
the second property. Its value is always
less
less
than
than
one whole?
one whole. Good one. What is the second kind of fraction I taught you?
Whole fraction.
Whole
So
fraction. What is the property in that?
uh
The denominator is a
the
factor of numerator.
yeah.
The
So like 8/4 or
yes.
9/30.
Good one. Okay. What is the third kind of fraction I taught you?
Third, a whole plus proper fraction.
So
So that's just a mixed fraction.
that is a mixed fraction. Okay. I told you in a way so that you can remember it easily. The first one is a proper fraction, the real fraction. The second one is a whole fraction. The third one is the combination of the first two fractions. That is the mixed fraction.
Oh, yeah, yeah.
Okay, and then I taught you about improper fraction. That is the interconversion of mixed fraction into improper fraction, which I saw that you were good in that. Okay, then I taught you about the next fraction, that is equivalent fraction. What is equivalent fractions?
I think the next fraction you taught me was improper.
Yeah, after improper I am saying. After improper.
Oh, after.
Yes, improper you might be knowing it.
The fractions what?
Improper you might be knowing it. The value is greater than 1 and the numerator is greater than the denominator.
Yeah.
Okay. Then equivalent fraction. What are equivalent fractions?
Equivalent fractions are two fractions that like that they can make up the same value if you divide them.
So we say that the simplest form is same. We say if the simplest form is same, and you told me that you can check it by doing the cross multiplication of the denominator with the numerator, right?
Yeah.
Okay. Can you tell me 5 equivalent fractions of 2 by 7? Yes. 5 equivalent fractions of 2 by 7.
Okay. 4 by 14.
Very good.
Um, 5 by 35. No, sorry, not 5. 10 by 35.
10 by 35.
Yeah. 4 by 28.
Okay.
12 by 42. And 16 by 56.
I think this should be changed. It should be 8.
8. Oh, yeah. Oh. Yeah, yeah.
Why don't you go serially? See, it's easy. Multiply both of them by 2. So you will get 4 by 14. Multiply them by 3. So you will get 6 by 21. Multiplied by 4. So 8 by 28. Multiplied it by 5. So 10 by 35.
Oh, yeah. You can do that too.
Yeah. No, going it serially is a easier way. rather than to write or go in a random way. Suppose for example, if I ask you, I am asking you a very basic question. Let me see how your mind works. So how many 4-digit number you can make using the digits 2, 1, 4 and 6?
How
I
many
will give
four-digit
you
numbers?
I will give you 4 minutes to write all the numbers that you can make from 2, 1, 4 and 6. 4 minutes I am giving you. You can think, and how much you can write, you write it. Okay, the time starts now.
Okay.
None of the digit has to be repeated. Repetition is
Oh,
not
okay.
allowed. Repetition is not allowed, and you have to form only 4-digit number.
Yeah.
That means you have to use all of the digits. Okay, time up. Tell me how many
Yeah.
numbers you have made.
Uh, Wait, should I tell you the numbers or how many?
No, you tell me all the numbers that you have made.
Okay. 2146,
Okay,
6214,
okay,
six. I mean, no, 2164,
Okay.
4612,
Okay.
1264,
Okay.
6124,
Okay.
4216,
Hmm.
6142,
Okay.
4261,
Wonderful.
1624,
Okay.
1264,
What is the number?
1264.
1264 you have already told me.
Oh, I did? Oh, yeah. Okay. Uh, 6412,
Okay.
4216.
You have
No,
already
no,
told
wait.
me.
No, sorry. 2614,
Okay.
2416. No, wait. 2614.
Okay. That is already written.
Oh, 2461,
Okay.
6421.
Wonderful. These many?
Yeah. Huh? Yeah.
So
I don't.
4 and 5 9, 9 and 5 14, 14 and 3 17 number you have wrote. I'm keeping it aside and will show you if you go it serially, see how much time it will take. So the smallest all of them number is 1. So I'm going from smallest to highest. So 1, 2, 4 and 6. Just replacing this. So 1, 2, 6, 4. Then replacing 2 by 4. So 1, 2, 6, 1, 4, 6, 2. Then 1, 4, 2, 6. Sorry, it should be 2, 6 first and then 6, 2. Then replacing 4 by 6. So it will become 2, 4 and 1, 6, 4, 2. How many numbers? 1, 2, 3, 4, 5, 6 with 1 in 30 seconds. Let us take 2 now. So fixing 2 now. So going from smaller to greater. So 2146, 2164. Then replacing 1 by 4. So 2416. Then 2461. Then 2614. 2641. 6 numbers with 2 as well. Now going with 4. Starting the number starting with 4. So if I want to write the number in the increasing order, I can write 4126, then replacing these two numbers. So 4162, then replacing 1 by 2. So
Oh, I know. I mean in
4216,
order.
4261, then replacing this by 6. So 4612 and 4621. Then fixing 6 now. So 6124, 6142, 6214, 6241, 6412, 6421. Now see, this is the highest number I can make. This is the smallest number I can make. And if I'm going CLE, see how much time it took already. Just not more than 2 minutes.
Yeah.
Alright, so don't randomize yourself. The
Okay.
randomized part I will take care of, because I will ask you random questions. But if you start thinking randomly, it will not help you out. Always
Yeah.
have a procedure to say. So when I say tell me 5 equivalent fractions, you multiply it by 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6. Okay, if you start thinking random numbers, then you will forget which number I multiplied. So you go serially. Alright.
Okay. Yeah.
So understood. Now see, you can see none of the number is left. What I did was
Yeah.
I got from the smaller step, went to the larger. You could have started from here, go backward. Are you getting it?
Yeah, yeah.
Can you do one more now if I give you four more numbers?
Sure.
Let me see. So 1, 2, 5 and 7. Your time starts now.
Okay.
You keep saying the number and write the number. I will also write.
Okay. 1, 2, 5, 7.
Very good.
1, 2, 7, 5.
Wonderful.
1, 5, 2, 7.
Wonderful.
1, 5, 7, 2.
Good one.
2.
No, 1. Keep 1 and replace 5 by
Oh
7.
yeah. Oh yeah. 1, 7, 2, 5. 1, 7, 5, 2.
Wonderful.
Now, uh, 2. Okay, wait. 2, 1, 5, 7, 2. Huh?
Yeah, keep.
Should I keep writing?
Yeah, yeah.
Okay. Should I keep saying it out loud or should I just go on?
No, no, you keep writing and saying as well.
Okay. 2, 1, 7, 5, 2, 5, 1, 7, 2, 5, 7, 1, 2, 7, 1, 5, 2, 7, 5, 1. Oh,
Then start with 5.
yeah, 5. Okay. 5, 1, 2, 7, 5, 1, 7, 2, 5, 2, 1, 7, 5, 2, 7, 1, 5, 7, 1, 2, 5, 7, 2, 1. Then, okay, 7, 7, 1, 2, 5, 7, 1, 5, 2, 7, 2, 1, 5, 7, 2, 5, 1, 7, 5, 1, 2, 7, 5, 2, 1.
Wonderful. See, you have improved your efficiency. Now you
Yeah.
have done the same thing in 3 minutes 21 seconds. And now this time you wrote all the numbers. All the
Yeah.
24 numbers. Are you getting it?
Yeah.
Very good. Well done. Okay. In the last class, I taught you about the horizontal division, which you already knew when I asked you some questions from the improper one. You remember the horizontal division? The horizontal division
Oh,
is,
yeah.
yeah, it is like suppose I give you uh, 234 divided by 13. Can you tell me what will be the quotient? What is the first number that I should write?
What? What do you mean first number? Like 234 divided by 13.
Yeah, what is the first number that should come?
Oh, wait, if you do it normal way, yeah, 234.
Yes. So what is
Yeah,
the first
that's the
number I
first
should
number.
write?
What? Think about the answer.
Okay.
Oh, answer. I thought you were saying like how to divide it in a
No, I'm not asking how to divide. I know you know how to divide. I'm asking what is the
No,
first digit that will come in the quotient.
quotients. Uh,
See, okay, I'm asking you, can 2 be divided by 13?
no,
Can 23 be divided by 13?
no,
Means it can 13 go in 23 times in 23. How many times 13 can go in 23?
once.
One time. So the first number is 1.
Oh, oh yeah. I thought. Yeah, I don't
Okay?
know how you were asking like
Okay,
that.
it's
Okay.
okay, it's okay. I will ask you further questions. Let me explain the first one. So what is the
Shoot.
remainder? If 13 will go one time in 23, what will be the remainder?
Uh, wait. What? Oh, yeah. 10,
10. And then 10 will along with 4, what the number will become?
14, or 104.
104. 13 will go how many times in 104?
Uh,
8 times. So you don't know the table of 13 as well, that I think. You might not be
yeah,
knowing the
no,
table of 13.
no.
Okay. See, you have to remember this at least. The table of 13, 17 and 19. Alright.
Uh,
Because if you are going to divide with a 2-digit number, it's very difficult for you. Okay, so I think the division part for the long division methods, if the numbers are big, are you able to divide it? For example, suppose I give you 275,164 divided by 271. If the number comes like this, then without the help of the calculator, can you do this?
I mean, I could try,
How you
but
will
I
try?
never
What is
tried.
your approach? What
I
is your
never.
approach? Tell me.
I would just try to see how much 271 could go into 275. Yeah.
Do you know the
No,
table of? Okay, tell me. What should I write? Good approach. Good
I
one.
would, yeah, once.
Once. Very good. So I will write 271. Then 4 is the remainder. Then what's the next step?
Uh, bring the 6 4 down.
Huh?
No, wait. What? Yeah, I never learned how to do this. I don't.
Okay, this division you don't know how to do. So you will bring down
No, they
the,
never taught
you
us.
will bring down this one.
Oh,
Now 271
oh,
will go how many times in 41?
uh, 0.
0 times. So you will bring down another number 6. Now 271 will go how many times in 416?
Once.
So 1 into 1 is 127. Then the remainder is going to be 6 minus 1, 5. Then 41 minus 27 is 14. Then now this will go how many times in 1454?
I would have to do like another division for that. I would have to write it on. Can I
Yeah, please write it.
do it on? but I think only six, right?
6 times.
Yeah, because if you did seven, it would be like a little over.
If you go 6 times as well, it will be over only. See, what is 6 into 7?
Huh? Oh, 42.
And 4 is the carried over. So 6 into 2 is how much?
16 into 2? Or
6 into
oh,
2.
6. Oh, 12.
12 plus 4 is how much?
16.
16 is greater than 14.
Oh,
Are you multiplying 271? Just checking with 271? No, don't do that. Okay, so this is what I was trying to tell you. Remove two numbers from the first two numbers. Do you know the table of 271? Nobody knows that. In fact, I don't know.
no.
Do you know the table of 27? That also we don't know.
No.
But we know the table of 2. So we remove the
Yeah.
first two digits, and you can remove the first two digits from here as well. Now 2 will go how many times in 14? 7 times.
What? 7.
But when you multiplied 7 by 7, what is the carried over? 4. So 14 plus 4 is 18, which is greater than 14. So it will not go 7 times. So we will reduce it by 1. Let's check with 6. 6 into 7 is 42. So 4 is carried over. So 6 into 2, 12 plus 4, 16. That is also bigger number. So it will go 5 times.
Okay.
Are you getting it?
Yeah.
So 5 into 1
Can
is...
I use that
Hmm.
quick?
Tell me.
Can I use the bathroom? Real
Yes,
quick?
yes.
Yeah, I'm back.
Okay. Okay, how many properties you know in mathematics?
Properties like addition, dot.
That is the operation.
Yeah. Like, can you explain what properties are?
Okay, so properties, there are basic 6 basic different properties in mathematics. These are closure property, commutative property, associative property, distributive property, additive identity,
Oh,
multiplicative identity. Out of
yeah.
this, how many of
So
you know?
I know distributive property, uh, community, commutative property, and
Okay,
associative.
okay, so let's start with the first property, that is the closure property. So closure property exists for...
Yeah, 1 second. He's getting some cramps. Just give me some a few minutes.
Okay, sir.
Yeah, his bank.
Yeah.
Okay.
And he fell from bike today, and he got some like muscle uh, cramping and some. He suddenly got some pain, so we had to
Oh my God.
take
So
care of
are you fine now?
Yeah, I'm fine.
Okay. So you should say like this. Don't say like this. I'm fine.
him. Yeah.
Okay. So there are four kind of operations that we do in mathematics on the four kinds of numbers as of now. So the numbers are natural numbers, whole numbers, integers, and rational numbers, which I already taught you. The fourth kind of operation that we do is addition, subtraction, multiplication, and division. Okay, so I will start from a very basic question. You can think in your mind and you can answer. No need to hurry. Just think and answer. If I add two natural numbers, will I get a natural number? Is it true? Adding two natural numbers, I can take any natural numbers. So if I add two natural numbers, will I get the natural number only?
I mean, I don't,
You
I
can
don't,
do some
yeah.
you can do some
So,
stuff, some examples. You can take some examples in your mind. Just do it normally and think and tell me. You know what are natural numbers? The numbers starting from 1 to infinity. 1, 2, 3, 4, like this.
yeah, I know.
Yes. So if you add them, take any two natural numbers. If you add them, what is the result you are going to get? Is it the result is also a natural number or result in something else?
It's also a natural.
Natural number. So we will say that natural numbers are closed under addition. Natural numbers are closed under addition.
Adi.
What about subtraction? If I subtract two natural numbers, will I always get a natural number?
No.
No? Can you
Because,
give me a counter
yeah.
example?
Uh, well, maybe if you do 1 minus 1, you would get 0.
Wonderful. Good
So,
logic. So that means they are not closed under subtraction. Now anything which has got some addition to do is also true for multiplication, because multiplication is the continuous addition.
yeah.
And which is not true for subtraction can never be true for division as well. So if you take two natural numbers, let us say 1 and 3, and if you divide 1 by 3, this is not a natural number. So this
Yeah.
we say that natural number are not closed under subtraction and division, but for addition and multiplication they are closed. All right.
Yeah.
Next number. Can you say that adding two whole numbers will give you always a whole number only?
Yeah.
What about multiplication as well?
Yeah.
Multiplying two whole numbers, you will get two whole numbers. What about division? Oh, sorry, subtraction. If I subtract a whole number from another whole number, will I get always a whole number?
Um, I mean, yeah,
Yes?
right. Actually, but if you do like 1 minus 1, you would get 0. That's not a whole number.
Yeah, that's a whole number only.
Oh, wait. Oh, yeah, yeah. No. Yeah. So, yeah, you would always get a whole number.
But what if you subtract 2 from 1?
2 from 1, you would get 1.
I'm subtracting 2 from 1, not 1 from 2.
Oh.
I'm asking you to do 1 minus 2.
Yeah. Then, yeah, we wouldn't, because that would be 0 0.5.
Huh? 1 minus 2 is 0 0.5.
Yeah, 0 0.5 plus 0 0.5.
1 minus 2, I'm asking. What is 1 minus 2?
Oh yeah. Uh,
Okay, so you have been promoted. You have to do this sheet
wait, what?
in grade 7. I told you that you completed B25, my dear. You know all the subtraction easily. You have done it already. So 1 minus 2 is how much? 1 minus 2 is negative 1. Don't you know this?
Oh,
What's your
yeah. I was
confusion now?
thinking. No,
Why you
I
are
was.
saying 0.5?
Yeah, no, I was just thinking in like for decimals. I wasn't thinking for
I'm just
integers. Yeah.
I'm not into decimals, my dear. I haven't started decimals yet. I'm just with whole numbers, integers, and rational numbers only. So what is 1 minus 2? It is negative 1. So is negative 1 a whole number?
Uh, no.
No. So that means the whole numbers are not closed under subtraction. So they are neither closed under division. What about integers? If you add it to integers, will you always get an integer?
Mm, yes, right? Because
If you multiply two integers, will you always get an integer?
yeah.
If you subtract two integers, will you always get an integer?
Uh, yeah.
Yes. If you divide two integers, will you always get an integer?
Yeah.
Okay. So minus 2 by 3. I am dividing negative 2, one integer by another integer. Is that in an integer?
Yeah. But I thought like you said if something works for subtraction, it also works for division, right?
Yeah,
Or
that
is
I
it the
told.
opposite?
No, I told you if something is not working for subtraction, it will not work for division as well. I didn't told the way that you are saying that if something works for division, it will also work for. If something works for subtraction, it will also work for division. I didn't told you that. I told
Oh,
you if something doesn't work for subtraction, will also not work for division. This is the base
oh,
criteria. Suppose I said that suppose I want to know whether you have passed your grade 10 as well or not. So I will ask you, have you passed grade 8? So I will say no. Then I don't need to ask for grade 10. I know that if you haven't passed grade 8, it is but obvious that you haven't passed grade 10 because that is the first thing that we need to do. So if something is not valid for subtraction, it is never valid for division as well. But it doesn't mean the other way. It may be valid for subtraction, but it may not be valid for division. For addition and
oh,
multiplication, it is valid. It is true for addition and multiplication, but not for subtraction and division. Alright?
yeah.
So if I do minus 2, I took one integer and another integer. Is minus 2 by 3 an integer? No.
No.
So it will not be closed under division. What about
Yeah.
rational numbers? If I take two rational numbers, let us say 1 by 2 and again 2 by 3. If I add them, will I get a rational number?
No. Actually,
No.
no. You go. You go. Sorry.
What about multiplication? If I multiply these two numbers, will I get a rational number?
Yeah.
What about subtraction? If I divide them, will I get a sorry, if I subtract them, 1 by 2 minus 2 by 3, whatever result I will get, is it a rational number?
Uh, well, so I have a question. What if you do like, hmm, what if maybe you do 10 by 3 minus 7 by 3? It would be like 3 over 3. That would be one whole number, right?
So is it not a rational number?
Rational number? I
Suppose
mean,
you got 1. 1 is not a rational number.
one
What
is
is
a
that?
whole
What
number.
is 1 is a whole number, that's fine. But what about one is a rational number? What I taught you about the definition of a rational number? I made you write what are rational numbers. Just see.
No, that's just fun. What?
Do you remember what is the rational number? The first day when I taught you about the number system, the first four kind of numbers. What is the definition we wrote for a rational number?
The exact definition, I don't remember, but it's like kind of like a
Any
it's like
number
a
which can
fraction.
be written in the form of p by q, where q cannot be equal to 0. I made two conditions. Q should not be equal to 0 and p and q must be integers. You remember that?
Oh yeah.
So can 1 be written as 1 by 1?
Uh yeah.
Is it an integer?
Yeah.
Is this also an integer?
Yeah.
Then it is fulfilling the condition of a rational number.
Yeah.
I told you that 4 by 2 is a fraction.
Mm.
You said, no sir, you told me it is a whole fraction. Yeah, it is a whole fraction. But is it not a fraction? It is a fraction. Any
Yeah.
number which have a numerator, which have a denominator is always a fraction. Is always not a fraction, it is always a rational number. The rational number includes the negative fractions as well. What is the basic difference between a fraction and a rational number? So rational numbers are the numbers which include all the numbers in that, like negative 1 by 2, negative 2 by 3, negative 5 by 4. But fractions are only positive. It is like 1 by 2. You can't say I have negative 1 by 2. No. Negative 1 by 2 is a rational number. It is not a fraction. But positive 1 by 2 is a fraction as well as rational number. Alright?
Yeah.
Okay. So I'm asking you, if you subtract a rational number from another rational number, will you always get a rational number?
Yes.
Yes. What about division?
Uh mm, yes, right?
Yes, it is true for division as well, except you take 0, because division by 0 is not allowed. So suppose I
Yeah.
ask you 2 by 3 divided by 0. So that is not allowed. So because of this 0, we say that this is not closed under division as well. So for division, none of the number system is closed. But for multiplication, all the numbers are closed. For addition, everything is closed. For subtraction, only integers and rational numbers are closed. So this is the first property. So we will end with this in today's class. In the next class, I will teach you about more about the other properties. Till then, I'm going to give you some homework. So your homework is to do all the sheets from B1 to B24 in the grade 7.
Okay.
All sheets. It will hardly take you 1 hour from
Okay.
B1 to B24. Okay, it's basic addition subtraction, just to have a quick note on that, so you can do all those sheets. All right, if you have time,
Yeah.
no hurry. Okay, take your own time, do it, no pressure from my side. It's a recommendation.
Okay.
Okay, there are a lot many sheets, but I have to first check it out whether you are good in subtraction and addition. All right, chalo,
Okay.
with this I'm going to end this class. Bye.
Okay. Thank you.
Bye.
Bye.